To see if this would work, a series of patterns must be sent through the model. Since I have two thread controllers available, I'll send two pattern series through. One will control the eyelids with 2 patterns in the series, and the other will control the left deltoid muscles with 4 patterns in the series. While the patterns are going through, I'll investigate this last column on the anticipation table. The action column holds 2 instructions on how the entry is to be processed. The first is whether the pattern is to be sent or not. Why would the pattern not be sent? It makes no sense. Actually, if the pattern is not sent, then the thread controller acts as an input filter to prevent the body from responding to background data. Why would it not want to respond to background data? Well, if an animal is hunting its prey, it would be too busy smelling the roses to notice the scent of its prey. By filtering out the background smells, it can concentrate on the important ones. I guess that is why I cannot detect the smells in my home, and how I get used to the taste of water in a new location. The thread controller filters it out. The second instruction is whether to wait for a command to be processed or not. Typically, the system would wait for the pattern to be received before passing the pattern on. The system would not wait in situations such as instinctive reactions, where a single input pattern could trigger a series of independent actions. This would allow the system to respond faster. This is going to take a while. While it's chugging away, I might as well try to figure out intelligence. Is it a good thing or bad? On the good side, it allows for complex operations such as pack hunting. On the bad side, it floods the system with numerous patterns. This is like running video games on the computer controlling a nuclear power station. The system would be off on some foolish quest when it would be time to lower the control rods, daydreaming when it should be trying to detect that poisonous snake hiding in the bushes, or that crocodile sneaking up on you. So is intelligence good or bad? That question would have scientists up in arms if the evolutionary system had not already provided the answer. The evolutionary process has 2 factors, and each species locates its balance point within the system using them. Question: where is evolution going? Answer: nowhere. It is just removing the randomness from the selection process. Then what killed off the dinosaurs? Yeah, right. Wrong. What killed off the dinosaurs? But how could tiny mammals kill off huge dinosaurs? Mammals had a huge advantage over the dinosaurs, but could they exploit it? Well, there is clear evidence that the increased survival rate caused many sliders. Mammals lost, or did not develop, armor, poisons, and massive size because we did not need them to survive. But this was not enough. We needed a crippler to make it harder for the weak to survive. If an attribute gives the species an advantage, it would be copied. After all, crocodile mothers are starting to take care of their young, and some snakes and sharks are giving birth to live young. They are copying these strategies, but they are not copying warm blood, and they are not copying intelligence. Why? Because these strategies are cripplers meant to harm a species. So where do humans fit into this picture? When love forced humans to pair up for safety, predators stopped hunting us. Why have we avoided extinction so far, when other species like the Neanderthals did not? We replaced the laws of nature with our own set of restrictions that served us well until... No. So, how is the model ever going to pull the series of patterns out of this random jumble of inputs? Easy. Count them. Since the number of times the heart beats will be different from the number of breaths taken, each thread can be differentiated by the number of times it was run. All patterns having the same count, or one less in case the cycle was in the middle when sleep started, will be of one thread. The patterns will also be in the correct order, which means the next reference number will be the pattern below it until the end of the thread is reached. In this case, the next reference number will be the first pattern in the thread. So I guess I can just sit and watch it happen. Now that it has finished sleeping, the anticipation table is broken into two segments. The lower portion is used by the first thread controller, while the upper portion is used by the other two controllers. By counting and grouping the entries, the two series of patterns come right out of the jumbled inputs. The eyes open pattern in the first row is linked through the next reference entry to the second row of the table. This is the eyes closed pattern. In turn, this is linked with the first row in the table through its reference number. Moving to the thread controllers, it becomes evident how they make use of these entries. Once the expected pattern is encountered, the thread controller loads the next expected pattern, which, in this case, is eyes closed. The pattern is sent through the null adder to the pattern buffer where it waits to be processed. The thread controller sends the pattern along with the pattern's row number and search width. When it is processed, the pattern response table is quickly moved to the top of the search sector and the search begins. With a smaller group of patterns to search, the process of locating matches takes less time.